Okay, so for this time, we're going to um, evaluate if yung magiging approach natin sa structural design ng ating beams is singly or doubly. Ang yung first na procedure is for us to determine kung ano ba yung magiging beta factor. And using ACI, table 22.2.2.4.3, our beta factor can be calculated based doon sa magiging value ng ating uh, FC prime. If our FC prime is greater than or equivalent siya sa 17 megapascal, but less than or equivalent sa 28 megapascal, our beta factor is 0.85. And if our FC prime naman is greater siya sa 28 megapascal, but less than 55 megapascal, we can make use of this equation here to determine the value of our beta factor. If our FC prime is greater than or equivalent sa 55 megapascal, 0.65 naman yung magiging value ng ating beta factor. Also, um, yung next na gagawin is for us to determine yung ating effective depth. If hindi given yung effective depth no, sa isang problem, we can make use of some approximations. As for example, if single layer lang yung ating yung mga reinforcement ng ating concrete, we can make use of this approximate equation na H minus 65 millimeters. And kung two layers naman, yung arrangement ng mga steel reinforcement, H minus 90 millimeters naman, yung gagamitin natin na approximate equation to determine our effective depth. Now take note, we can only make use of this if hindi given yung mga clear concrete cover, yung diameter ng ties natin, tsaka yung diameter ng ating steel bar. However, if given yung mga parameters na yon, we can make use of this equation. Pero assuming na single layer lang yung steel reinforcement. So yung D natin will now be equivalent to H minus CC plus clear concrete cover plus diameter ng ties plus per diameter ng longitude ng reinforcement divided by 2. So after solving for the beta factor tsaka yung effective depths, meron tayong dalawang methods para ma-determine yung MU max. So sa first na method is we can make use of the equation ng Cmax. Yung Cmax, ito yung location ng ating neutral axis at maximum condition. Once na may Cmax na tayo, we can solve for our Amax. So yung Amax naman, di ba, yung equation ng depth ng compression block, di ba, is equivalent to beta 1 times yung C. So, if we're going to multiply our beta tsaka yung Cmax natin, masasolve naman natin yung ating Amax. So, that is for method 1. Kasi, meron tayong dalawang equations kasi para masolve yung Mu max. Yung second na method naman is we can make use of the equation no, ng ating steel ratio at maximum condition para masolve naman yung coefficient of resistance at maximum condition. Once masolve na to, itong dalawa na to, masosolve na natin yung ating Mu max. And also, yung ating strength reduction factor ay nakadepende siya doon sa na-assume ninyo na strain ng ating tension steel. Kasi sa strain ng tension steel, dalawa kasi yung ginagamit. Pwede siya na 0.004 and pwede rin siyang 0.005. So yung 0.004, allowed to ng code na gagamitin natin. However, based on my evaluation, medyo magkakaproblema ka when it comes to designing yung doubly reinforced na concrete. Kasi nakatry ako dati, yung ginamit ko na strain is yung 0.004. Yes, nakapag-design ako ng doubly reinforced na beam. However, nung chinek ko siya through structural investigation, bumaba yung capacity kaysa sa demand. So that's why yung recommended pa rin na strain ng tension steel natin is 0.005. So we have to always assume na yung strain ng tension steel natin is nasa tension controlled siya. So once na ma-determine natin yung ating MU max, i-compare natin ito doon sa factored na bending moment. If our MU is less than or equivalent sa ating MU max, therefore, you're going to design your beam as singly reinforced. Sa such cases naman, na mas mataas yung MU kaysa sa MU max, then you're going to design your beam as doubly reinforced.